Welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, July 15th. Looking at significant wave heights for the South Pacific Ocean, we see a significantly improved pattern compared to weeks past. Remnants of a gale, seas 29 feet, are in the central South Pacific, pushing north, and those seas were a bit higher earlier in the 31-foot range. But more importantly, a small gale, right now with seas in the 37-foot range, are developing in the far South Pacific and forecast to push north while building in height, pushing well up into the California, Central America, and South America swell windows. This is good news. To kick things off, let's start looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales form, help direct their path. We're looking for a trough. That is a push to the north in the jet stream. That, of course, sort of sets up a clockwise flow aloft and down at the surface, and that is the hallmark of low pressure in the southern hemisphere. Of course, low pressure, if strong enough, and abutting up against high pressure helps generate winds. Winds generate seas. Seas, as they radiate away from the fetch area, turn into swell. Swell, when it hits your beach, produces surf. All right, so we have a trough right there. Nothing particularly huge at the moment, but decent amount of winds. 140-knot winds starting to feed up into it, and that is helping to get some circulation going, specifically more right down around in this area here. But as we move into later this evening and Monday morning, you can see the winds start pushing further to north, opening up the fetch area or the trough, deepening it and making it more supportive of gale development. And that continues, and look, it pushes the upper level winds are pushing almost due north, and that's typically what you want to get a swell with fetch, pushing towards the north, and that's what you need to reach California and Hawaii. Anyway, by Monday night, winds forecast to 130 knots. That's pretty good. Continuing into almost Tuesday morning, then the gale the upper level trough starts fading a bit. Also notice under New Zealand on Wednesday, a ridge starts building. That is, winds start pushing south. That supports high pressure in the down at the surface, and that helps basically shut off the swell production machine. So even as we are into Wednesday here, a bit of the trough still lingers, but then it pretty much is faded out. You can see this big ridge starting to build, sweeping east across the Pacific, and then that continues, only being reinforced with winds now to 150 knots forecast over the central South Pacific. As we get into Saturday night, we're almost a week out, and into Sunday, maybe a little bit of a trough here in the far southeast Pacific. Forecast building, but well outside of the Southern California swell window, and the ridge even builds stronger a week out under New Zealand. So basically, the short of this, it looks like there's a good supportive environment for the middle part of this week in the Central South Pacific, but after that, things shut down. Let's go take a look at the surface level charts. So here we are, surface level pressure, surface level winds, and as expected, so you see actually remnants of a previous gale here, and we'll get into that in a little bit. 35-knot winds. Look, again, pushing well to the north, not particularly strong, but pretty far to the north. That helps shorten the distance between where the fetch is and where California is, and the shorter the distance, the less swell decay, and that's what you want relative to southern hemiswells. The other thing is, you notice the islands here, Tahiti and associated islands, a little bit east of there. That's what you want so you don't run into the Tahitian swell shadow. But right now, the big focus is 50-knot winds right here over a good solid area. A little bit shadowed at the moment relative to Tahiti. The swell path actually doesn't go straight north. It actually curves sort of like that relative to California, but still partially shadowed, but getting good traction on the ocean surface. Roll this out. Look at the fetch dies, but 45 knots by tonight into Monday morning, pushing on, we'll say north-northeast, unshadowed, looking good. Also another strong fetch here, but pushing south of no interest. So we'll focus here. Broad area, 40-knot winds Monday night, just pushing to the north. You get the general idea. Fading Tuesday, 30, little bit 35, little bit of 40-knot winds down here. Secondary fetch, tiny patch of 45-knot winds. Nothing though compared to what was. Fetch fading as we get in Tuesday night, 30 to 35 knots, and then slowly dissipating and getting ready to move out of the swell window by, there you go, come Wednesday night. So a good long stretch from now till Wednesday night of fetched, aimed reasonably well to the north, aimed at California, Mexico, Central America, you get the drill. Sideband energy for Hawaii, but Hawaii will not be the primary focus. Anyway, roll this out, continue. Now we know the jet is supposed to start pushing south. The ice line somewhere down around 65 here. We see no fetch of interest as we get into Friday. And there you go. We see fetch all push south. Not a good sign. And that basically continues into Sunday. And there we are. We're at the end of the model run. So one good solid system forecast. Let's take a look at the wave model charts now. Before we do that, we're going to go back in time a little bit. Wednesday this week, July 11th, small gale developed. Actually, a primer gale ahead of that, but we're not even going to concern ourselves that it was tiny, never had particularly large seas, of no real interest. This system started developing under New Zealand on about 18Z Wednesday. By late Wednesday night, seas were 41.7 feet here in the core of this system. On the Great Circle paths to Hawaii and the U.S. West Coast, unshadowed, I think it was about 213 degrees relative to southern and northern California. That is west of the Tahitian swell shadow coming up this side of the Tahitian Islands. And also in the Hawaii swell window, I think it was about 197, 193 degrees, something like that. Also unshadowed, but mostly aimed to the east. That's the big problem for both locations. Most of this energy was really targeting, let's say, Peru, that kind of area. Anyway, you see it continue on, pushing east, fading out as we got into Friday. We'll just sort of roll this out. We had a bit of an issue with our server. We had a new system develop Saturday morning. We don't have the data. The server was down, but seas got to about the 31-foot range, pushing north. That's, again, mainly just a teaser swell. And you can see the remnants of that system come Sunday afternoon here in the Central South Pacific, 29-foot seas. But it is the new system down here southeast of New Zealand. As of right now, 36-foot seas developing, lifting north, 40-foot seas, basically effectively 39-foot seas, come early Monday, continuing north, 39-foot seas, blooming again, 18Z on Monday with near 40-foot seas, but we'll say good 39-foot seas. And every foot or two, foot or two doesn't make a difference. 2 or 3 feet can make a difference in terms of period, in terms of number of waves in a set, all that kind of stuff. So we are very close about monitoring down to the foot level whenever possible. Seas continue, and notice the trajectory was to the northeast. We'll go back and look at this in a second. But as we get into, let's say, Monday night there, still, what was that? That's about 38-foot seas. This is for that little system there, pointing south, of no concern to us. Tuesday morning, still 30, 32, 34, 35-foot seas, maybe 36-foot here in this area. In the California swell window, lifting north some, then fading finally Tuesday night, maybe 32-foot seas. But system continues to sort of hang in there while pushing east out of the California swell window. Another little pulse of 32-foot seas come Wednesday night in the Southern Cal, mainly swell window, but insignificant compared to what was happening earlier. All right, so let's run the whole way through this. Keep your eyes here. Watch the trajectory to the north and northeast. Looking pretty good. That's about as good as you're going to get for most any southern hemi storm, and pushing well up to near 40 south, cutting the distance, the travel distance from 40 south to 60 south is 20 degrees. That's 1,200 nautical miles, cutting 1,200 miles off the travel distance up to California. So that helps to ensure a little bit more size, a little bit more consistency, and unshadowed, that helps increase the number of waves per set as well. While we wait for those series of swells, the more local picture, local wind swell, what's going on? Wind swell, east, what is it, like 4 feet at 8 seconds or something, 8 or 9 seconds, pushing into exposed east-facing shores of the Hawaiian Islands right now. In fact, we'll take a quick look here. Hilo Buoy, east of Hawaii. You see spectrum, wind swell, focused in the 8-second period range. Size, rough estimate. Looking down, 5 feet at 8 seconds there. Let's go take a look over east shore of Oahu. Makapu Buoy. There you go. There's your wind swell. All the energy focused in the 8-second. Not a whole lot going on out at 16 seconds. Size, history right there. Looking down, 4.3 feet at 7.7, 8 seconds from, the east-northeast, something like that. Good for about, waist high or so east wind swell. And then looking at California, high pressure, 1032 millibars, but not ridging east. Whatever fetch it's generating, 50-knot fetch, out in the oceans, not really doing anything. Good for maybe, some little 3-footed 8-second wind swell or something like that. So let's roll it out. What's the forecast? Hawaii continuing. In fact, we'll scroll up here. Tropical system, tropical wave, maybe a depression, something like that, developing east of the Hawaiian Islands. So you have high pressure here, low pressure here. The distance between the two helps tighten up the isobars a bit. That generates wind, and wind generates wind swell. So that's to continue. For Hawaii, we're kind of ignoring California because just a whole lot's not going on there. High pressure continues as we get into, we're at Tuesday. There we go. So you get the general, oops. Yeah, we'll put this back over. There you go. So you can see time as well. And there we are. All right, and continuing into the tropical system starts pushing south of Hawaii, but falling apart. 20-knot fetch by late Tuesday night into early Wednesday morning. More wind swell along the east shores of the Hawaiian Islands. Now notice at this time, high pressure starts ridging into California. Heat low inland creates a gradient there. North winds building 25, almost 30 knots along the Oregon, Northern California border. That'll help build wind swell. The fetch continues relative to Hawaii as we get into Thursday, but fetch also building 30 knots off the North California coast. Eddy flow, that is, see there's that little heat low there. You get a counterclockwise flow in the northern hemisphere around there, and you get south winds along the California coast. That's an eddy flow. While you have your 30-knot north fetch over Northern California, that'll be good for wind swell. Wind swell continues for Hawaii as well on Thursday. See what happens as we go to Friday. Friday, east fetch fades out relative to Hawaii, but continues solid for California. We'll just sort of roll, and mainly this wind swell is good probably down into somewhere in Monterey Bay or so. Once you start getting further south, because it has a further travel distance and it's kind of tucked in there, the more north angle swells has a harder time getting in. So you get much less size and much less direct energy further south. Anyway, wind swell continues into Saturday and then starts fading out. The fetch is just generalized 20-knot north fetch, but also little fetch starts building here relative to Hawaii again. And supposedly, don't ever believe the model's this far out, but again, more low pressure starts building south of Hawaii. Roll this out, and we're at 180 hours out. So more of the same, basically. Plenty of wind swell, not huge at all for California. It will have its moments, and then starts weakening. But Hawaii, pretty good run of easterly wind swell expected. All right, let's take a look longer term. What's going on with Madden-Julian oscillation, and of course, El Nino. So as usual, we'll start looking for presence or signs of the active phase of the MJO. The MJO, when in the active phase, helps support storm formation in the southern hemisphere rather indirectly. And what we're looking for is slackening of trades in the West Pacific in what we call the Kelvin Wave generation area, that area from 170 west to about 135 east, 5 degrees north and south of the equator. When you get calm winds or a westerly anomalies in this area, that helps take warm water that's normally here, push it east, subsurface under the equator. That's known as a Kelvin wave. And that a Kelvin wave, if the winds are strong enough, eventually it reaches the Galapagos Islands over here in the East Pacific, starts gurgling to the surface, creating a warm water slick, and that warm water slick helps create condensation in the atmosphere, precipitation, and that helps feed the jet stream. So right now, winds are pretty solid from the east over the entire equatorial East Pacific, and we're really just interested in the area 5 degrees north and south of the equator. And then to about the date line, maybe a little bit over the date line. We're only talking 5 degrees north and south of the equator, so right, in that box there. But a rather light, kind of a light trade pattern over the East Pacific. Looking at anomalies, differences from normal for this time of year, yeah, those easterly winds, that's pretty much normal. Maybe just a hair bit stronger than normal from 140 west to, almost the date line, and then pretty much normal over there. So no westerly anomalies, no real sign of the active phase, the MJO. If anything, maybe a light diminishing, fading bit of inactive phase, the MJO. Let's go look for more evidence. And what has been the pattern in the past 5 days? This is 850 millibar wind anomalies from, so that's up about 4,700 feet, but a pretty good proxy for what's going on at the surface. East Pacific here, West Pacific here, that's South America, Mexico. There's New Guinea there. Kelvin wave generation area. Draw a box pretty much right along in here. something like that. And you see westerly anomalies in half the Kelvin wave generation area, easterly anomalies in the other half. This is back on the 9th of July and the 10th. You kind of go, you see the same pattern has pretty much been holding through July 13th. Let's go take a look at the forecast. Now here's another way to look at it. This is this is the whole planet on one chart. Again, 850 millibar wind anomalies. Dateline goes right down the middle of the chart. Kelvin wave generation area between these two tick marks. We go down the chart. Blues are easterly anomalies. Yellows are westerly anomalies. We go down here. This past history. Certainly looks like the inactive phase of the MJO has controlled the latter half of June. Tried to fade a little bit around the 4th of July, but then it built up strong again the past week and a half or so. Limited to the dateline, westerly anomalies building here in the far western Kelvin wave generation area. And then the forecast here for the next week, easterly anomalies continuing. So this sort of split pattern. Easterly anomalies in the eastern half of the Kelvin wave generation area, westerly anomalies in the western half, the easterly anomalies a little bit stronger. Now this still seems overstated compared to what the CFS model's showing. We'll get into that in a moment. But then we look at the outgoing long wave radiation models. Okay, so this is basically the amount of sunlight reflecting off the ocean's surface. Less sunlight reflectivity. Blues, negative numbers here, suggest cloudiness. And of course, cloudiness is typically associated with evaporation, associated with low pressure, and that would mean the active phase of the MJO. And so, right, as we saw from the other charts, active phase of the MJO over the western half of the Kelvin wave generation area, the inactive phase, or something that looks like it, over the eastern half, and that's what's happening now. And basically, it's forecast to hold for the next 8 days, and then supposedly both of them disappear or start fading per the statistic model. But the dynamic model says no. Instead, the same pattern's supposed to hold. So hard to tell exactly what's going to happen. The situation we're in right now is not great, but not bad. It's sort of, we're halfway there. Sure wish the active phase of the MJO would just push on off to the west, but it apparently doesn't have the strength yet to do that. But we look at phase diagrams. Another way of looking at the same thing. Assume you're looking down on the North Pole of our planet. The active and the inactive phase move from west to east from the Indian Ocean over the maritime continent, across the West Pacific, under the United States, across the Atlantic, across North Africa, back to the Indian Ocean. Where the heavy dot is where the active phase of the MJO is. So in the maritime continent, just on the verge of trying to move into the West Pacific, the green line is the forecast track. And what we see is, and the further away from the circle here, the stronger the active phase of the MJO is. So it's supposed to strengthen for a day or two, and then fade a little bit while moving off to the east, making it about to the center of the Western Pacific 2 weeks out, fading a little. But basically that, that track per the ECMF model. The GEFS model says, basically the same thing. So they're in track. The MJO expected to make it to the West Pacific about 2 weeks out. And an upper level model. So greens are the active phase of the MJO, supportive for precipitation. Yellows, oranges, the exact opposite. There's South America. There's New Guinea there. Kelvin wave generation area on the equator, right about in here. So it looks like the active phase of the MJO is in the Kelvin wave generation area and forecast to slowly migrate off to the east and out of the Pacific by 18th of August, something like that. So, we have a month of that or so. And then the inactive phase of the MJO is to build in the far West Pacific about the 4th of August, and then make its trek across the Pacific through the end of the model run, the 24th of August. All right, let's dig a little deeper. The CFS model, same deal. Here's the date line here. There's a whole planet on one chart. Kelvin wave generation area, basically between these two tick marks going up. The forecast, here's where we are today. Westerly anomalies in the West Pacific, easterly, or in the western Kelvin wave generation area, easterly anomalies in the eastern half of the Kelvin wave generation area. That's supposed to last. Each of these tick marks here are 1 week. A week from now, those easterly anomalies are forecast to be gone. Westerly anomalies building strong. Maybe a westerly wind burst, if anything, developing in the core of the Kelvin. There's 150 west. That's right in the core, or east. That's the core of the Kelvin wave generation area. But also notice westerly anomalies starting to fill the Kelvin wave generation area and holding strong on down for the next 4 weeks is a month-long forecast, but that looks like a westerly wind burst there, and westerly anomalies building as we get later into this run. Let's go yet further out. So this is a little different. We're now looking up. So this is past history here, but it's still the CFS model, 850 millibar wind anomalies. One thing that really stands out here, and this has been on this model for a long time, is a 3-month run. You see yellows and oranges the whole way through the final frame of this model on October 12th. What do we see? Yellows and oranges. Those are westerly anomalies. And where's the Kelvin wave generation area? Between these two tick marks. So for the foreseeable future, after we get maybe a week out, westerly anomalies in control. Let's put the MJO over top of here. Of course, active phase of the MJO building starting in the next day or two, holding into, let's say, August 8th. Westerly wind burst forecast in the core of the Kelvin wave generation area. Not a moment too soon. We'll get into that in a minute. A week inactive phase supposed to follow, but still westerly anomalies in control out till about, let's say the 1st of September, and then another active phase of the MJO, and with another bit of maybe westerly wind burst type looking indicators here in the pretty much the whole month of September. So what's going on? We overlay the low pass filter. Here we go. Okay, so the solid contour suggests areas biased towards low pressure. And so this is kind of the hallmark of El Nino. When you see 1, 2, 3 contours all set up right over the core of the Kelvin wave generation area, and this is the exact opposite of last winter. See these dotted contours? So all this pattern is moving slowly off to the east, just like the active-inactive phase of the MJO pattern, but this moves far slower over a period of 2 years or something like that. So here's the last fading remnants of La Nina, basically south of California, forecast to be gone by let's say mid-September, while and that would be like a high pressure bias that breaks down just in time for fall over California, maybe allowing precipitation in, while the low pressure bias builds strong in the Kelvin wave generation area. The date line, it runs right up here, so even past the date line over to probably a point about equal to Hawaii. That is good news. This suggests a more normal, if not slightly enhanced, storm track for the fall and winter months, and also perhaps improved chances for precipitation into California as we get into this coming winter. So what's going on in the ocean now? Subsurface. Okay, we're done with the MJO. Let's talk longer term, El Nino, that sort of stuff. We're looking for signs of El Nino, certainly not La Nina. We consider that to be gone now. West Pacific here, East Pacific here. We're at depth. These little X's are the sensors on the anchor lines of the TAA buoy array, a string of buoys strung across the equator used for monitoring El Nino. Temperatures, 30-degree anomalies in the far West Pacific. That's pretty normal. 28-degree isotherm right here. Now, it had made progress to about 149, I believe it was, a couple of weeks ago. Backtracked a little bit. That's suggesting that easterly trades are strong, or that whatever Kelvin wave might have been in the area is starting to lose ground. That would not be unexpected. The 24-degree isotherm, strong though, pushing the whole way into Ecuador. Pretty solid, certainly suggesting at least a normal, if not slightly enhanced than normal warm water temperature pattern pushing to the east. In fact, let's look at anomalies, differences from normal from this time of year. Certainly what we see is no cool water in the subsurface East Pacific. We see warm anomalies, 1 degree above normal, like a river of water flowing subsurface. This is the Kelvin wave thing we talked about. Remember, westerly winds in the Kelvin wave generation area help take warm water that's here, push it to depth. It travels as a bubble, just like that there, pushing into Ecuador, then eventually reaches the surface and creates a warm slick up there, which gets caught by the trades and pushed back across the Pacific on the equator, and that helps fuel the jet stream. All right, so here's our Kelvin wave. We've been watching it for a couple months now. It's still there, 3-degree anomalies. This chart actually had it backed off to 2 degrees, but it's still there, 3 degrees as of the latest run, and 2 degrees solid the whole way out till, where is that? That is, let's say basically south of Hawaii. So from south of Hawaii the whole way into Ecuador, warmer than normal water subsurface pushing to the east, getting ready to erupt to the surface. Here's another version of that, just a different modeled version. You even get a better picture. What is this? 1 to 2 degree anomalies here. That's pretty much what we saw. And 3-degree anomalies out in here. Ecuador is here. So it's erupting a little bit east of Ecuador from, let's say, the Galapagos the whole way out to a point about south of Hawaii. Pretty good. This looks positive. That means more warm water erupting to the surface. But what we really want to see is another westerly wind burst to take warm water, push it to depth, and build a second Kelvin wave. El Nino is not made off a single Kelvin wave. It takes a series of them, and that in turn takes a series of active phases of the MJO to create those westerly anomalies to push the warm water east. To try and confirm whether that model data is true, we look at sea level anomalies. This is from the JSON-2 satellite. Basically, strip out all the waves on the ocean, strip out all the wind waves, strip out the tides, and this tells you what the height of the ocean is without waves, just like we're looking for a bump. And this is a 0 to 5 centimeter, maybe a couple little pockets of 10 centimeters, but mostly 5 centimeter bump on the ocean surface. Here's the date line. Here's the equator. That's South America. That's the New Guinea there. So warm water. So warm water at depth expands. That creates the bump on the ocean surface. If we saw negative anomalies here, that would mean that La Nina, cool water, is flowing east, but that's not the case. Lots of warm water, and you can see it actually seeping out through the maritime continent into the Pacific and just waiting to be tapped by westerly winds to create yet another Kelvin wave. So right now, good sign, potential weak El Nino developing. Upper ocean heat anomalies, basically the same story. East Pacific here, West Pacific here. We're back October, November last year. That's the remnants of La Nina. It faded out. First Kelvin wave generated by a very strong pulse of the active phase of the MJO back in February. Took warm anomalies, started pushing them east, and you can see it. This is over time, warm water moving to the east. Now it's stalled in the April-May timeframe, this Kelvin wave. It started in February. We're at April-May. It stalled, where's that? About south of California on the equator. Then finally made its big push as we got into the late May, June timeframe. And that's when the eruption started here. You see warm water at depth, but not so much anymore here. We need more westerly anomalies to create a second Kelvin wave. But notice, I mean, the whole equatorial Pacific is awash in warm water. We just need a little bit of wind to start pushing it. And typically, you know, in a normal year, the active phase of the MJO really doesn't do a whole lot in the summer time frame. It's more in the fall when it wakes up and starts doing its thing. But, you know, any bit would be helpful. And why do we say that? All right, we're looking at sea surface temperature anomalies. Differences from normal this time of year. Yeah, we have a little bit of cool water here off of Peru and Chile. That's been the case. This is called the Nino 1.2 region. Basically draw a box right in here. Kind of a noise level region, but interesting to watch. But we do see warm water here along the off of Ecuador and the Galapagos, and in pockets out here to about, let's say, 115 west, but not nearly as strong as it was. It's almost like the Kelvin wave eruption has stalled. Notice we're seeing these little bits of cool anomalies too, suggesting maybe those easterly trades that are blowing here are creating upwelling and sort of cutting off the Kelvin wave from doing its thing. So we want to see those easterly anomalies dissipate. Supposedly in about the next week that's supposed to happen. But the official El Nino monitoring region is here, 120 west out to about 170 west, 5 degrees north and south of the equator. Sort of like another Kelvin wave generation area, only this is for monitoring El Nino. Yes, warmer than normal waters, but not particularly warm. But it was this area that really caught our eye, how the warm water has backed off the flow. The upwelling has been shut down by the upwelling of warm water, which I guess they actually call downwelling, is actually shut off, and there's a cool upwelling pattern or cooler upwelling pattern taking hold right now. But you look at this. This is a sea surface temperature trend the past 7 days. A couple of pockets of real warm water starting to show up. This wasn't here. It was more of a cooling pattern. And it's almost like this leads the charge in some of these others. So whatever lack of warming we see right now, this chart suggests that's supposed to be short-lived, and upwelling is again supposed to start occurring with warm water making its way to the surface. Not only there's the Galapagos, not only off of Ecuador, west of the Galapagos, but then it's also occurring steadily out to about 140 west and then holding neutral from there. And here's the overview. Certainly warmer than normal water in, well, the El Nino monitoring region from here to here. See some neutral, or the last little bits of La Nina sort of hanging on here. but 5 degrees north and south of the equator. Well, this is 20 degrees between these, so 5 degrees would be about along here, up to here, out to here. Draw that box. And temperatures generally doing pretty well. We can't show you the actual temperatures in these regions. The site that did it took a hit over the weekend. I'm sure they'll all work to get that data back. But the short of it is, we're not in negative territory, but we're not super warm either. We'll call it a mild warming trend is occurring in the official Nino 3.4 region. So what's going on in the atmosphere above, that's sort of driving? We see this sort of all of a sudden lack of warming in the main area for monitoring El Nino. Let's see what's going on. One of the indicators in the atmosphere is the Southern Oscillation Index, difference of pressure between Darwin, Australia, and Tahiti. Negative numbers means lower pressure over Tahiti, meaning the active phase of the MJO. Positive numbers suggest the inactive phase of the MJO, and it kind of looks like here we looked like the active phase was setting up. Now all of a sudden it's just come to a grinding halt. Today's value 9.54. This is noisy though. 30-day average sort of evens it out. We were looking also in that as active with negative numbers going steadily down to minus 7.92, but now all of a sudden we've rebound minus 4.02. So that sort of suggests either the active phase of the MJO has muted, or the inactive phase is trying to raise its head a little bit, or something else is going on. The 90-day average, basically the same story. We were heading negative down to minus 2.73. We thought, looks like El Nino is starting to get going, but now it's sort of taken a pause. And then our other index, the ESPI index. So basically, it's the difference in rainfall in the area north of Darwin, Australia, and Tahiti. When the index is negative, that means things are drier in this region. And sure enough, it's taken a big hit, minus 1.22. You want to see this? We were on the border. We were like at minus 0.08 or something, on the verge of, okay, here comes the start of El Nino. The index was going to go positive, and all of a sudden, boom, here we are back down a whole, full in one on the index, suggesting, again, cool water in this region, and that's exactly what we're seeing on all the charts. Our hope, and that's all we can say, is that it's due to whatever this easterly wind burst, the last little bit of La Nina just hanging on, just causing upwelling and sort of stomping on our Kelvin wave right now and not allowing it to upwell to the surface. We believe that it will at some point, and that'll drive this index back towards the positive range. But as of right now, we're on a bit of a hiatus, just waiting for something to change. Now, the CFS model is basically saying, I'm taking a much longer view of this. And you know what? That's probably the right way to go. We look at this every week, but the reality is I'm looking at it every day. It's real easy to get caught up, and you can't see the trees from the forest, and you can't tell the big trend, but we're always looking for signs of anything going one way or the other. So here we are, July. This actually shows that it's sensed that the temperatures have dropped a little bit, a quarter of a degree above normal. We were thinking maybe 0.4, but this is confirmed data at about a 0.25 of a degree. But the trend still says, well, we're supposed to push up to 1 degree as we get into September above normal. As we get into October, let's say 1.4 degrees above normal, and 1.5 degrees above normal as we get into November. I mean, that's not some super El Nino, but that's not just a modest El Nino would be somewhere around half a degree above normal over a 9-month period. But this is looking more like, well, maybe 1 degree above normal with a peak at 1.5. That would be a moderate El Nino if it were to happen. And that would be good for this, of course, this fall, this summer, probably the latter half of the summer, the latter part, let's say maybe late August or so, we'd start seeing the jet stream starting to change in the southern hemi, and we maybe get a flurry of storms in the New Zealand corridor, maybe. But certainly, if nothing else, as we get into fall, then we should notice the change in the northern hemi, Gulf of Alaska, Dateline region, and certainly into the winter. And, you know the general story here. But, of course, this is a model. It is fallible, but this seems like a reasonable, maybe a little bit over-enhanced. So this is supposed to be the more conservative of all the models. So for right now, the trend is still on towards El Nino. So to wrap things up real quick, a series of Right now, small southern hemiswells in the New Zealand corridor for the most part, pushing towards Hawaii and the U.S. West Coast, but a stronger storm in development. Actually, it's a gale, but with 38-foot, 39-foot seas projected, aim well to the north. Good run of surf could potentially develop. Watch the wave models, weather models, see how this develops over the next 3 to 4 or 5 days, something like that. But it looks like some real surf could be on the way. Nothing off the charts, but solid at least. And in the meantime, yes, our El Nino continues. We really want to see the active phase of the MJO wake up and just stomp the heck out of the last little bits of La Nina, but it still has not given up the ghost. Our upwelling in the Kelvin Wave in the East Pacific from Kelvin Wave number 1, still having a bit of a problem. We're hoping that is short-lived, but we'll just have to wait and see. So stay tuned. So we'll do it again next week, same time, same channel. Thanks for watching. Bye.